Hello everyone. So myself Shilpa Raj, intern at AGSRT. So in this session, I'll be talking about urban planning site suitability analysis model builder using ArcGIS Pro software. So what is site suitability analysis? For site suitability analysis, it's a spatial analyst extension tool in ArcGIS Pro, which is used to identify the most appropriate locations. Like for example, we are planning a site suitability analysis for urban development. It will identify the most appropriate locations for the same, like based on accessibility or environmental conditions, infrastructure, etc. It can be multiple factors. So similarly, it is used in variety of problems. Like you have when you have to locate a new sky area, so and you have to deploy troops in a military operation, and when you want to locate a firefighting cruiser, fire stations, like so. Here in this session, we'll be using workflows to identify the best areas for a new housing development. So for that purpose, model builder is used. So for automating this process, we use model builder, which is a visual programming tool. It analyzes spatial data, automate process and connect various geoprocessing tools. So this is the best way to simplify complex process and saves time as well. So for this purpose, I have used Masla as my study area for performing site suitability analysis. Masla is located in Raigad district, Maharashtra. It is a gradually developing town. So the data I have used in this session to perform site suitability analysis is just a demo data which I have with me to show you how it works. And for identifying suitable sites for new housing development, major factors or major parameters that should be considered are roads, water bodies, social infrastructure, slope, and land use as well. As I have said, Masla I have taken as the study here. So, for identifying suitable areas or suitable sites for new housing development, or like we have to consider major factors that should be considered. So, like for this session, I have used land use, which is an important parameter, and then digital elevation model, DEM data, elevation data for the slope analysis, and then road networks, which is in a shapefile form, and water body, and social infrastructure, etc. And next, for land use, I have downloaded the satellite image from Google and performed the supervised classification. And these are the DN values and their respective classes which I have taken. One as vegetation, two as agriculture, three water body, four barren land, and five settlement. So, and then elevation data for slope analysis, I have downloaded from Earth data. And as I already mentioned, roads in the vector form, water body, and social infrastructure, all is in the vector form. So, now I'll show you how to do, like, these are the, before it, these are the steps that are involved in the site feasibility analysis. So, before creating a model builder, I'll show you how to do a site feasibility analysis manually using ArcGIS Pro. So, for that, first, we need to start a project in ArcGIS Pro. And then you have to add the data you have. For that, we have to go to Map tab, add data, and we have to locate where it is and add the data. These are the data from adding it. So the first step is finding slope. For finding slope, you need to go to View tab, Geoprocessing. You have to search for slope, spatial analysis. For finding slope, we have to use data. For slope analysis, we are using elevation as input. We can give the input as elevation, and we can save the output raster. So we can give more slope, and we can give Z factor as 0.3080. That is because dim data will be in meters and coordinate system will be in degrees. So I have given the coordinate system 0, WGS 1984, 43 degree north. So this Z factor 0.380 adjusts the elevation value consistent with the ground distance in degrees. So I'm giving Z factor as 0.3080 and I'm setting the environment such as extent using the extent of land use and the mask also land use and we can find. So this is our law. And next step includes finding Euclidean distance, which is the distance to the closest source. We can find the Euclidean distance. For that, we have to go to geoprocessing tool and find search for Euclidean So we have to find Euclidean distance for all shapefiles we have. So we have road, water, and social infrastructure shapefiles. So we find the Euclidean distance for three of them. So I'll find Euclidean distance for roads first. How to Euclidean distance. I'll check the environment, extent, value, mask also, values. And we can click run. And next is of the distance of water body. Megan setting the action, language, and social infrastructure. So we finding Euclidean distance part is done. So next step involves reclassifying. First, we have to reclassify flow. For that, geoprocessing tools, we have to search for reclassify. Spatial analysis tools, we have to ensure that. First, we can reclassify flow. So, select the input raster as flow. Then I can classify. Then we equal interval and center. So now we need to think if we want our housing development in the steepest slope or left slope. So we can't we can't build house at the steepest slope, right? We have to give preference to the left slope area. So left slope, so we have to reverse new value. So 10 will be the most suitable area. So you can save the output after we classify slope and set the exit and run it. And next we are going to reclassify all other Euclidean distance structure. So next will be social infrastructure. Euclidean distance of social infrastructure we should consider for as the infrastructure. So we will classify um, with equal interval, 10 classes. And we need our housing development nearer to social infrastructure. So we can reverse the nuance and so that 10 will be the most suitable areas which is near to social infrastructure. So we'll save it and set the extent and run it. Similarly, we'll do for water body and roads. So in the case of water body, we are avoiding places near to water body to prevent the flood risk now. So we are not reversing the values here. We are giving most 10 most suitable areas far from water bodies. So I'm not reversing the values and giving it and setting the extent, land use, use and convex. And then last road. So we need a housing development nearer to roads. So when nearer to roads, where you want to build your house. So again, you can reverse the new values. 10 as most suitable areas, which is near to roads. You can save it. That's the extension one. This is the reclassification part. We have reclassified all the data we have. The next step involves weighted over there. So we'll give weights to parameters we are considering. So for that, geoprocessing tools, you know, spatial analysis tool. So first of all, we have set the scale. Here, in default, it is 1 to 8. We have to set 1 to 10. Otherwise, it will cause some problems with the user. So after that, we can add the features into the overlay. First, we have to add the land use. So adding land use in the overlay table. And we have to add other reclassified parameters. Reclassified roads, water, social infrastructure, and flow. We can add it. And then first click the land use and change the values. As I have already mentioned here, I have given DN value 1 for vegetation, 2 for agriculture, 3 for water body, 4 barren land, 5 settlement. So according to that, near to settlement, we should consider as more suitable areas for us. So we give the scale 10 for settlement if we need our housing development near to the city. And fourth is barrenness. We can give scale 8 so that it will be low conservation cost. And then 3 is water body, which we don't need housing development near to water body to prevent flood. Okay? So I'll give 1 to water body. And the 2 is agriculture. So I'm giving 5, scale 5 for agriculture and 1 is vegetation. We don't need to build our housing development near to vegetation. We don't need to destroy physical resources. So I'm using 4 for vegetation. And then next we have to set the influence percentage of all these features.
So, and the sum of influence should be 100. So I'm giving land use 35%, and roads I'm giving 25, housing development near to roads, and and water I'm giving 10%, and social infrastructure I'm giving 20%, and finally slope I'm giving 10%. No need housing development, keep the slope. So after that, I'm again changing values for roads and all. So all these features are in the scale of 10 with more suitability because we already defined reverse values. So, but in law we should restrict the steepest slope. For that, I'm restricting the steepest slope. Restricting. And also social infrastructure, I'm restricting the far distance. In water body, I'm restricting the places which is near to water bodies. In roads also, far places from which I'm also restricting. And that's it, and we can save it and set the external budget. And run it. You are checking all of the layers. So this is the final result of weighted overlay analysis. So here 10 indicate green part as the most usable area. And now I'll show you how to automate these workflows using model data. So for that, I'm going to analysis tab, model data. So for properties, you can change the name of the model and label of the model as you wish. And then first step is finding flaw. For that, we can search for flaw from geoprocessing tools and drag it to the model like this. And then let's click the slot open. So you can set the parameters like input cluster, we can select elevation and you can save it. And you can give the Z value 0.080 and you can set the environment here itself. And okay, so the input cluster will be coming here automatically. And next step involves Euclidean distribution. Search for Euclidean distribution in the geoprocessing tools and drag it here. We need to find Euclidean distance for roads, water bodies, and social infrastructure. So we need to drag. We need to so for roads, I'm setting good features. So how distance also you can save it. And I'm setting the extent mass. And then next is for roads. And save. Next is for water body. Let's say environment, mental land use, and then click OK. And next is Euclidean distance for social infrastructure. And separate and then click OK. So we can keep auto layout to finely arrange this one. And next step involves reclassify, as you know. So we search for reclassify. So we need input for reclassify. That is the output of Euclidean distance. For that, we'll select all of this and run it first. We'll select it and then click run. So it will be running automatically. That is done. We can go to reclassify. So, and we can drag it. So we have to find reclassify for slope, Euclidean distance of roads, Euclidean distance of water, Euclidean distance of social infrastructure. So we have to add it four things for all of the four parameters. I'll left click and open. So first I'm reclassifying the slope. Selecting the input raster and I'm clicking classify. Press I said we have to set equal interval and 10 classes. As I already mentioned, we don't need a housing development in the steepest slope. So we are reversing these values and saving it. Setting the action and clicking OK. So the input has come automatically. And next we are going to reclassify Euclidean distance of row. We have to select the input raster from model variable. So here there will be Euclidean distance of row. And then you can click classify, equal interval, the class 10. So we need a housing development nearer to road and reversing the values. Saving it, setting the extent and OK. Okay. Then next is reclassifying water body. Where you select the input raster from water variables. Clean distance of water. Classify. Equal interval. Then restriction. I'm not reversing values here because I don't need housing development near to water works. So I'll save it and then say extend and run it. Okay. Okay. Social infrastructure. Medium distance of social infrastructure are selected as infrastructure and classified. Equal interval, 10 classes. So here I'm reversing the classes because I need my housing development near to social infrastructure. I'm reversing values the same way. Um, and to set the so okay. So this is the reclassification part, and we need to select all these reclassification as well. So selecting it and drawing it. So it's done. And I'm again clicking auto layout to arrange this. Okay. And then next is weighted overlay. Weighted overlay. I'm dragging it here and right click, open. First, we have already done that. First, we have to load the land use into the weighted overlay table. So load the land use. And then all other parameters, reclassification of slope, roads, water, and social infrastructure and all that. And I'm setting the scale 1 to 4. It's taking so time. Okay. And we'll first select the land use and set the scale. As I've already set the scale, for 15 minutes, I'm giving 10. For 4 will be barren land. So I'm giving 8 to barren land. And then 3 is water body. I'm giving 1 to water body as I don't need my housing development near to water. And 2 is agriculture. I'm giving 5, scale 5 for agriculture. And 1 is vegetation. I'm giving scale 4 for. So that's it. I'm setting the next. I'm setting the sum of influences percentage, and as I said, sum of influence should be 100. So I'm giving land use same 35. Slope I'm giving 10. Roads I'm giving 25. Water I'm giving 10. 25. Water I'm giving 10. Social infrastructure I'm giving 20. Then next we can restrict the steepest slope areas. So restricting it. And I'm restricting the places which is far from roads, taking some time to reclassification of water, restricting waters from places near to water body. And next is social infrastructure. Okay, I'm saving the weighted overlay out raster. And I'm setting the X. I'm clicking OK. Okay. So this is how it comes, and we can run this weighted overlay. So you can right click on weighted overlay and run it. So the output is ready. So if you want, we need to display the output. So we can right click on the result and click add to display. So the result will be shown here. So these are the results. So green areas. There is no dark green areas here. Like some are here. So these green areas are suitable for our housing build. So this is how we automate process using water to connect with geoprocessing tools. So that's it about the session. Thank you.